Namaste everyone. Let us look into the second set of multiple choice questions. Here is the first one question. Electric field near an infinitely large charged metal sheet. So if you have an infinitely large charged metal sheet, how does the electric field vary with the distance? Varies inversely as the distance from the charge sheet. Second option varies directly as the distance from the charge sheet and doesn't depend on the last one. So all the options. You know that if it's a very large charged sheet, then the electric field at a distance r is given by E is equal to sigma by 2 epsilon naught. No r appears in the formula. That means electric field is independent of the distance from the charged metal sheet. It is uniform everywhere. So it is independent of the distance. So it looks very surprising. How does the electric field doesn't depend on not depending on any of the distance from the charged metal sheet, because charged metal sheet is infinitely large. It is something like looking into a sky just by sleeping on the ground. So if you sleep on the ground and take the photograph of the sky using a mobile, you will get the same type of a photograph if you go to the top of a building and take the photograph of the sky. So the height above the hill or above the building doesn't matter, and the sky looks very similar from the top of the building as well as from the bottom of the building. That height doesn't matter at all because sky is very infinitely large, so it looks similar at both the points. Similarly, for an infinitely large charged metal sheet, electric field at different points very close to it are almost the same. It is independent of the distance. So independent of the distance from the charge sheet. Yeah, second one. A parallel plate capacitor with oil as dielectric and its dielectric constant is given as 2 between the plates has a capacitance C. If the oil is completely removed, the capacitance becomes. So in a parallel plate capacitor, if the medium is completely filled with the dielectric, and if C0 is the capacitance without medium, then you know that C is given by K times the C0. C0 is the capacitance without any medium. And they say that now the dielectric constant is 2, and when this is removed, it becomes only air capacitor. Capacitor with the air as dielectric, which whose K value is 1. Now, what is that C0? So C is equal to 2C0 and C0 is equal to C by 2. So you have removed the dielectric, now it is C by 2. So answer is option D. Mobility of charge is given by. So you must be aware of some small formulas in different chapters, especially magnetism and current electricity and first chapters, electric field and charges. So those formulas may be the MCQ question. So here we have such a similar question. Mobility of a charge is given by. You know that mobility is the drift velocity per unit electric field. Drift velocity is E tau by m. Per unit electric field is E. So E gets cancelled. It is E tau by m. So better to know all these small formulas. Here is one again similar such problem. Dimension of Q E plus Q into V cross B. If you look into this formula, it is the formula for the force experienced by a charged particle in both electric and magnetic fields, and it is Lorentz equation, and the Lorentz equation is the equation for force, and force is F equal to ma, and its mass into acceleration m lt to the power minus 2. So this is the answer, option B. Better you know the equations, and we have such similar equations. For example, 1 by root of mu naught epsilon naught, that refers to the speed of light. So its dimension is lt to the power minus 1 and so on. Okay, we will move on to the fifth question. Ratio of magnetization to magnetic intensity. Magnetization to the magnetic intensity. Magnetism and matter is a chapter wherein you get plenty of new terminologies, new definitions, and new equations. So better you know all those things and their units, their dimensions, and everything. Here, the magnetization to magnetic intensity ratio, you know that it is susceptibility. Susceptibility is the ratio of magnetization to magnetic intensity. And it has no unit because m and h have the same unit. So this chi has no unit. Chi has no unit. So it is susceptibility. So in the same way, you have many formulas there. For example, magnetic flux per unit area is called magnetization, and magnetic moment per unit volume is called magnetization. Magnetic moment per unit volume is called magnetization, M. Like this, magnetic moment is current into area. So in this way, we have many similar formulas, small formulas. So better you know all these things in MCQ. So here now it is M by H is chi, susceptibility. Sixth one, mutual inductance of a pair of coaxial solenoids placed coaxially does not depend on. And you know, the mutual inductance between a pair of solenoids is M is equal to mu naught, number of turns per unit length in the first coil, number of turns per unit length in the second coil, area of the smaller coil, pi R1 squared, into length of the coils, coaxial solenoids. So pi R1 square, because it is the smaller area which enjoys the flux every time. So pi R1 square. R2 is not in the picture. Radius of the outer coil is not in the picture. So radius of the outer coil doesn't decide the mutual inductance. SI unit of magnetic flux is, it is measured in Weber. Number of magnetic field lines passing per unit area, it is Weber. That's why we write magnetic field V is flux per unit area. This is another formula that we get in magnetism and matter. So it is Weber per meter square, which is also equal to Tesla. So Tesla is the SI unit of magnetic induction, which is flux per unit area, Weber per meter square. So flux is only Weber. Phase difference between current and voltage in a purely resistive AC circuit. You know that in a resistive circuit, phase difference between current and voltage is zero. They are in phase. Ninth one, existence of electromagnetic wave were predicted by. So this one. So that existence of electromagnetic wave was predicted, and a new theory was given on light, and that is called electromagnetic wave theory, and that was done by Maxwell. So Maxwell proposed electromagnetic wave theory, electromagnetic theory of light. Whereas later on, Hertz experimentally proved it or confirmed it. Experimentally confirmed electromagnetic theory. So the usage of words should be very important. So who proposed, who predicted? Maxwell. And who experimentally confirmed it, or who proved it? Experimentally confirmed or proved. So electromagnetic wave theory was proposed by Maxwell and proved by Hertz. So now the answer is Maxwell, because it was predicted. Yes, answer A. Statement 1. Focal length of a lens depends on the wavelength of light used. Yeah, that's right. It doesn't depend. It does depend on the wavelength of light. And more the wavelength, lesser is the focal length. So this we will check whether it is correct or not. Suppose you take a lens, every part of the lens will act like a prism. You know that in a prism, the most bent color, most deviated color is violet, and the least deviated color is red. So if you take a prism and incident multiple multicolored light, that is composite light, maybe parallel beam of light also. Red light gets bent and it will be brought to focus at a faraway distance. So focal length with respect to red color is larger for that lens. So if you measure the focal length by using red color light, the focal length is larger. Whereas in the same composite light, blue colors are separated and they are brought to focus at a very close point. Blue and violet, of course. Violet is the most bent color, so it is brought to focus here. So this is the focus for the blue color. So the focal length with respect to blue color is less. So for a lens, focal length with respect to violet or blue is lesser than the focal length with respect to red. So you can write power is the reciprocal of focal length. We know it. Power is the reciprocal of focal length. So power with respect to violet should be greater than power with respect to red. And what else we can write? So in this way it goes on. Now their question is, the more the way, okay, first one is correct. Focal length depends on the color of light. Second one, the more the wavelength, lesser the focal length. This is wrong, because more the wavelength, we found that for red it is more, because red has a wavelength more than blue. We know it. violet is the least wavelength in the visible colors, and red is the most one. So more the wavelength, more will be the focal length. Should it be wrong? So answer should be first statement is correct, second statement is false. It can never be the answer for the first one, like this. So focal length is more for a lesser wavelength. Sorry, is more for more wavelength, less for lesser wavelength. So I hope you have understood this one. Yes. Condition for the fourth dark fringe. Condition for the fourth dark fringe in the case of Young's double slit experiment. They have put all the possibilities, phase difference, path difference, everything. So now if you write a condition for bright fringes, that is constructive interference. For bright fringe, the path difference should be delta x should be n lambda. And n can have 0 if it is a zeroth fringe, that is central bright fringe. N equal 1 for the first bright fringe. So path difference for bright fringe, third bright fringe, fourth bright fringe, you can write nth bright fringe into lambda. What about phase difference? Phase difference is equal to 2n pi. You know this. It should be 2n pi. N starting from 0 and n equal to 1, 2, 3 like this. 2 pi, 4 pi. It is an even multiple of pi's. Now for dark fringes. So what are the conditions for dark fringes? So when you answer one question, you see the possibility of answering all the nearby questions. So what is the condition for dark? For dark fringe, the path difference should be is equal to 2n plus 1 lambda by 2 or n plus half lambda. But remember, n starts from, if you write it like this, the n starts from 0 for the first fringe. This is for the first dark fringe. And n equal to 1 for second dark fringe, and n equal to 2 for the third dark fringe. You just imagine that the condition for the dark fringes is first path difference should be lambda by 2, second one 3 lambda by 2, next 4 lambda by 2. So it should be n equal to 2, then n equal to 3 for the fourth dark fringe, n equal to 3 for the fourth dark fringe. So if you put n equal to 3, n equal to 3, then 3 plus half, that becomes 7 lambda by 2. 7 lambda by 2, put n equal to 3. So it should be this one, 7 lambda by 2. Okay, and that is path difference. Phase difference should be, if you want to write the phase difference, first phase difference should be pi, then 3 pi, then 5 pi, then 7 pi. It should be 7 pi. So neither this one nor this one is true. It should be 7 pi. This is the fourth dark fringe condition. Okay. X-intercept of the graph of frequency along in x-axis and incident electromagnetic radiation versus kinetic energy along y-axis. Okay, kinetic energy along y-axis and frequency along x-axis. Graph for photoelectric effect will be like this. This is x-intercept and this is work function, you know it, and this is threshold frequency, nu naught, and slope is h. If it is kinetic energy, then slope is h. If it is a potential, then h by e. Slope is h. This is nu naught. X-intercept is nu naught. It is stopping a threshold frequency. Yes, threshold frequency. Pick out the correct statement from the following. Bohr's theory cannot explain stability of the atom. Yes, it is correct. Bohr's theory can explain. Okay, Rutherford's atom model did not give the stability of the atoms, right? Bohr's theory and so okay, this is wrong because Bohr's theory explained the stability of atom. Bohr's theory cannot explain the spectral lines of hydrogen atom. No, wrong. It explained the spectral lines. Bohr's theory is applicable only for hydrogen and hydrogen-like atoms. That is correct. And Bohr's theory can explain relative intensities of the frequencies of emitted in hydrogen. No, it cannot explain the relative intensity. Intensity of spectral lines is not explained. Brightness of spectral lines is not explained. It says that it can explain. No, it didn't explain. So only the correct statement is Bohr's theory is applicable only for hydrogen and hydrogen-like atoms. It is answer C. Okay, yes. Next, what is the ratio of radii of lithium nucleus to iron? You know that radius is a cube root of radius of lithium by radius of iron. is cube root of mass number of lithium, mass number of iron to the power 1 by 3, and lithium is 7 and iron is 56. It is to the power 1 by 3. 7 8s are cube root is 1 by 2. It is 1 by 2. Acceptor energy level in the following energy band diagram is. See, whenever we dope a material, a semiconductor material, with either pentavalent or trivalent atoms, the electrons of the the charge carriers of the dopant atom, they will not be either in the valence band or conduction band. You know that this is conduction band and this is valence band, and holes of the dopant atoms will form an energy level here. So this is acceptor level, very close to the valence band, and very near to the conduction band. There is an energy level formed by the donor atoms and donor level electrons. This is donor level, this is acceptor level, valence band, conduction band. So they are asking you what is the acceptor energy level. It is given by E1, this answer. Okay, fill in the blanks. Fill in the blanks by choosing appropriate answers given in the brackets. A current loop placed in a magnetic field expresses a torque. This is the principle of a galvanometer. You know that in a galvanometer, there is a coil placed in a magnetic field. When current is passed through the coil, it deflects, making the needle to deflect. And the deflection is directly proportional to current. That is galvanometer principle. So this is over. Self-induced EMF is also called the back EMF because that self-induced EMF flows in such a way as to oppose the cause. That's why it is called back EMF. Phenomenon that confirms that light wave is transverse. So it is polarization. Polarization always is true only for transverse waves. Only transverse waves can be polarized. So if a wave shows polarization, means it should be transverse in nature. Nucleus with same atomic number but different neutron number. Atomic number same means it is isotopes, and different mass number, isotopes. Dash is an inorganic compound of semiconductor, gallium arsenide. Yes. And of course, conductor remains. Oh, there are more answers here. We have answered everything, right? Polarization, interference, conduct. So 1, 2, 3, 4, 5, 6, 7. So you have to cut down one. You will have only 5 options needed, and you'll be given one extra. Okay. Thank you. Thank you for listening to me.